All right, what's the solution of AX equals to B? And then we still use we used the matrix. And here, right, since it's a 3 by 4, and we need 4x here, 4 by 1, eventually we will get B1, B2, and B3. We got here, and then we first create something. Since it's not 0, 0, 0, so we have to really take account of, if we do some animation, we have to take account of the B1, B2, or B3. So what we have to do here is make another matrix. We'll include the B1, B2, and B3. Okay, let's do the elimination. The first thing here is the last row. If we know that, if we use the first row as add the second row and then or multiplied by -1 and then give it to the last row, it will become 0, 0, 0, 0. 1, 2, 2, 0, 2, 4, 6, 0. B1, B2, B3 minus B1 minus B2. The first thing, and the second thing, what we will do here is the first and the second. So 1, 2, 2, B1, use B2 minus B1, subtract B, so it will be not 4, 0, 0, 2, 4. All right, 0, 0, 0, 0, B3 minus B1 minus B2. So that's how we get our matrix here. The first thing we have to notice is that here it means in our equation, the last row means 0, x1 equals 2, which means, so if we want to have a solution, B3 definitely will be the sum up of B1 and B2. So that's one condition we have got. And of course, the second one we have to think of here, for since this will be satisfied, we just give some random values. Given B1 equals to 1, B2 equals to 5, then B3 have to be 6. Only under these conditions we can really satisfy our our conditions or the equations here. So it means that we have 1, 5, 6 as B. So, and that's the first step. Second step, we just intention make our three variables 0. It means that the x3, 2, and equals to x4 equals 0. We just say something here. There equals to 0 because that's the three variables. Okay. And then we get x1, x2, x3 equals b1, and then, all right, here's a mistake. It should be b1 minus 2b1. So here is 3. So we can get x3 equals to 3 above 2, right? Yeah, exactly. And the x1 equals to minus 2. Here we got a special solution that the x1 minus 2, x2 0, x3 and x4. This we can go with this combination of x1 to x3, we can really get our desirable b, and then to make this function can be solved, right? Because with this one we can always get the b2 and b1 and b2 to b3. All right, and then we talk about the ax equals to 0. Actually, in the last session, so we already get the vector space of it. Should be something like maybe 3 minus 2, 1, 0, 0, 2, 0, minus 1, 0. And here, if we just add this minus 2, 0, it will be the solution for this x. Why it's like that? Why it's something like that? We can have a easily proof here. So here what we got is for instance, a and the particular solution, right, which refers to this one, will equals to b. That's something we got. And also what we got in the previous session, a times xn, the ln, right, equals to 0. So here we just xp, xn, right, the first and add the second equals to b. So all right, so it means that the particular solution and the long solution, we can really get the x here, and then with a we will get the b here. So always the xp and as well as the xn will always be the solution for this equation, and the xp plus xn is just we have right here. So that's something we can really easily prove why we should really have the solution like this. And also another question is that does the x or the x form a vector space? The answer is no. Why is like that? Because it doesn't really cross the 0, 0, 0, 0. Given no matter how hard the C and D will be, but as always, this equation will never be 0, 0, 0, 0. So there's no vector space. All right, now let's dive into some more cases here. And when we're just talking about the M, the matrix, we're assuming it's a M by N matrix, and M is bigger than N. For instance, we can give an example of 1, 2, 6, 5, 2, 1, 1, 1. This matrix, and M equals to 4, N equals to 2. So if we talk about the rank, of course, rank is something like among M and N, we get the minimum one. Since this one has a full rank when it comes to the column, so it will equals to 2. And the question is solutions we can get. So which means that if we get 1, 2, 6, 5, 2, 1, 1, 1, multiplied by x1, x2, because here is a 4 by 2, then we have to have a 2 by 1, so we can get the result of 4 by 1. So it will be B1, B2, B3, and B4. We have to know that always the 1, 2, 6, 5, 2, 1, 1, 1 can be 1, 0, 1, 0, 0, 0, 0, 0. This is for sure. And equals to something. If first we deal with ax equals to 0, so it will be 0. And then we can find out that there's only the particular solution to it. That is x1 equals to 0, x2 equals to 0. So the only solution we can get 0, 0. And if now we have ax equals to b, what we can get here is whether it have, if we are really lucky enough, fortunate enough, we can get a solution. For instance, if we have 1, 2, 6, 5, 1, 2, 2, 2, 1, 1, 1, x1, x2, let's say equals to 3, 3, 7, 6. So it's like I just add the two columns together. So obviously we can get a xp equals to 1, 1. That's the only solutions here. But if we are not lucky enough, we get something like here, 4 instead of 3, then we will get no solutions. So the answer for something like this, if there's a m by n matrix, and when the m is bigger than n or n is smaller than m, what we can get here is whether it has only one solution or there's no solution at all. Okay, that's it. Then let's go to the next case. So if it's really the reverse, m, let's say, still is bigger than n, but now we get m is the column and n is the matrix, is the row. Okay, so this one is, let's say, is m, and this one is n. As we know that always in this case, it can be something like 1, 0, 0, 1, something like this. The rank still equals to n equals to 2. Since here there are 4 variables, x1, x2, x3, and x4. And we only will get like 1b, 1, and b2. There are more x than the equation itself, so always there will be infinite solutions to it, because we have the free variables is m minus subtract by 2 equals to 2. So this is our free variables, and the PV variables is 2. As long as there are free variables, it means that we can assume the free variables equals to 0. And then we can get absolute, for instance, in this case, the 2 equations just regarding the, let's say if x1, x2, those are the pivot variables, we can get 2 equations of x1, x2. So we definitely will get one solutions here, the particular solutions for x1, x2. So it means that if we have free variables, always we will have a infinite solutions here because of the free variables. All right, that's the second case. And the third case is M is like a square matrix, like a 1, 2, 3, 1. So in this one, we will have the rank equals to 2, equals to m, and equals to n. And of course, this one it's simple. We can really make a, let's say, 1. First, we will make the 2 0. So we just like -5, 0, 3, 1. And then we'll just do something like 1, 0, 0, 1. So always this square matrix can be converted to something like this. And so it only have if the function is ax equals to 0, always the x1 equals x2 should be 0. So there's no, for this one, there's only one solution. And for ax equals to b, since there are 2 variables and the 2 equations, always we can get a special x1, x2. So they only have the unique one solution. And then all we have discussed about is that whether the column or the rows has the full rank. But what if there's no full rank out there? For instance, if the rank is smaller than n, and also the rank is smaller than the m. Actually, that's what we have really discussed it about in this case. In this case, eventually it can be something like this. And we have discussed about that if it has solutions or not really depends on here. For instance, if it's B1 minus B2 minus B3, if we see that B1 is not equals to B2 plus B3, then there definitely will be no solutions here, right? But if we really it satisfies this condition, B1 equals to B2 and then B3, then we can really take account of something above. And then it is really like what we discussed here. It will have a infinite solutions here. So the key here is depending on this, the 0, 1. It should all satisfy the conditions. And if it's satisfied, then we have infinite solutions. If it doesn't satisfy, then we don't have any other solutions here. All right. To sum it up, the key here is to identify the free variables. So how many free variables we can get depends on the rank also. So if we have a n equals to r, n is the column. Let's always see that the n is the column and the r is the rank. If n equals to r, it means that whether it has the only solutions here or we don't get any solutions. But if n is not equals to r, it means that we have the free variables because the n minus I equals to free variables here, free variables. Then if we have free variables, then we can get infinite solutions, or we cannot get any solutions because it doesn't really satisfy the 0, 0 here. All right, so that's really what we have discussed about today about AX equals to B and its solution. Thanks for watching. I'll see you in the next